Hello everyone, today we're going to be learning about systems of equations with your host, Mr. Canfield. Our first problem, system of equations, is graphing. The way to solve a graphing problem is, system of equation, is you have to have in the right formula. And the formula we use is y equals mx plus b. It has to be in this formula exactly in order for it to work. So as we see up here, this top one is in y equals mx plus b format. The bottom one is not, so we have to fix that. So it will be 5y equals negative 2x plus 10. It's still not complete though, because there's a 5 here, and it's not complete. It needs to be just y. So we're going to cross out the 5 and divide it under both. So we get y equals negative 2 over 5x plus 2. So now we have both. We have our first one and our second. So let's erase that and rewrite it. So now we have y equals 1/2 x plus 5 and y equals negative 2 over 5x plus 2. Now, we're not done because we need to graph this problem. So we're going to draw our simple little graph right over here. And we're going to do this one right here first. So we're going to go up 5. 1, 2, 3, 4, 5. I'm going to get a different colored marker for this. So there's our first point. And then we have to move, it's a positive slope, so it has to be going up. So we're going to go down 1, 2 over 1, 1, 2 over 1, 1, 2 over 1. And then you have to use a straight edge, but I don't have one, so we're just going to go make a nice little line right here. That is our first line. And then our second one is going to be up 1, 2. And then it's a negative, which means it's going to be going down. So we're going to go 1, 2, 3, 4, 5. And then we're going to go over 1, 2. And you can't do another one of these, I don't think. 1, 2, 3, 4, 5. Over 1, I guess you can. Let's do that. And then we're going to go up 1, 2, 3, 4, 5, and over 2. And this will be our line. So now we have an intersecting point, which is right here. So we have to determine where that is. So first, we always do x first, which is the horizontal line. So it's over 1, 2, 3. And then we go on the y-axis, which is a vertical line. And we go 1, 2, 3, 4. So we have negative 3 and 4 as our slope. But that's not the only kind of problem you can get. There are 3 different kinds. We either have a line that intercepts, at a point, which is called a one solution. Or we have parallel lines, that do not touch, and that is called a no solution, and we write that as such. last, we have an infinite solution, which is where we just have one line, because technically there are two lines here, but they're both on over the same thing. It's called collinear, which is all real numbers, and you write that in this fancy little thing like this. Just like that. Little fancy R. Up next, we have substitution. We substitute one variable into another. With this problem, we're going to be taking this and substituting it to replace this y right here. So to write it out, we get x minus 9 equals negative 7x minus 1. Because we replace the y here with this equation right here. So then we have to, we're going to cross out, let me get a different colored marker. We're going to cross out this guy and flip him over here, which becomes plus 7x. So we get 8x, and then we're going to take u and add u over here, and we get 8x equals 8. And then we're going to divide this number right here over here. So we're going to cross them out, divide by 8, and 8 divided by 8 equals 1. So x equals 1. There we go. So we have x, but we also need y, because we're not done yet. So we take this question right here, and we plug it into an original. So to do that, now we know that x equals 1, so we're going to do y equals, and we know our x is 1, so x equals 1 minus 9. That's what we have, and 1 minus 9 is so y equals negative 8. So we have our x and our y, so it becomes, in our slope formula, we have 1 and negative 8 as our final solution there for substitution. And again, with this one, you can get no solution and all real numbers. If you were to get no solution, you would end up with a problem, a result equaling of something like 5 equals 10. Well, we know that 5 does not equal 10, so that makes it no solution. There's no variables whatsoever in this. You just get numbers and they equal another number, and that's not correct. But if you were to get something like 2 equals 2, well, 2 does equal 2. There's no variables here. Notice there's no x or y anywhere. If 2 does equal 2, which is correct, then it becomes all real numbers, because it's equal to itself. And there we go. So our last problem is elimination. To solve this one, we have to have the x's or the y's equal themselves. So here, we're going to multiply the x's to find our y. So to do that, we need them equal the same number, which is greater common GCF. So we're going to multiply the top one by 2, because 5 times 2 is 10. We're going to multiply the bottom one by negative 5, because we want it to be easier, and a negative and a positive equal out to a 0. So we get our new equations over here, which will equal to 10x plus 6y equals negative 14. And then our next equation is negative 10x minus 35y equals negative 15. This is our new equation. We're going to add a big old plus sign right here, and then here comes the elimination part. The x's eliminate themselves and become 0, but we don't show that. That's the little secret. We don't show that part. but just know that it's 0. Now we're left with the y's. So we take 6y plus negative 35, and that equals negative 29y. And the other, we have it equaling negative 14 plus negative 15 is equal to negative 29. So 29 divided by 29, negative 29, equals out, because we're going to cross this one out and divide it by negative 29. That equals out to be 1. Y equals 1. That's our first, but that's just why we need x as well, since we eliminated x. So we're going to take this base 1, and we're going to plug it into an original, not our new. This is a remake. This is what we created. We're going to plug it into the original. We're going to do the bottom one because this one's easier. So we're going to do 2x plus 7 times 1 equals 3. So we have here, we have 2x plus 7 equals 3. Well, 3 minus 7 equals negative 4. And then we have our x, so we have this. We're going to take the 2 and cross it out, divide it by, and we get x equals negative 2. So now we're going to write this in the correct format, and we have negative 2, 1. There we go. Super simple and easy. Now, again, the same rules apply when we're working with the other kinds. If you get two numbers that equal the same, such as let's say 0 equals negative 7, two numbers that equal different, 0 does not equal negative 7, giving us no solution, just like substitution, same thing. And if we get something like 5 equals 5, that is correct, 5 does equal 5, so we get all real numbers as our answer. Thank you for watching. I hope you learned something. This is Mr. Canfield. We'll see you later. Goodbye.